Hello everyone, Dev Victoria is here and welcome back to another episode of our first person character controller video series. In this episode, I'm going to focus on how did I make the camera moving, rotating left and right and up and down. And for that, actually, the inspiration could be the third person character controller's gun movement, actually, because this is what reacts to the up and down movement of the mouse, and the whole character controller because this is what reacts to the left and right mouse. And also there is a great news because at the time of the recording, this ECS samples has been updated to the entity 0.50. This is now a current code. But let's get back to my implementation. Basically, the mouse has two movements, left and right and up and down. The left and right translates to a horizontal rotation, and that should be done by dots player level because the dots player character should face on the direction it is going to, basically. But this dots camera target is going to inherit this horizontal rotation value, but only this is the component should rotate up and down as well. And as it rotates, then obviously the non-dots camera target going to pick up that rotation, and hence the virtual camera is going to behave the way we want to behave, facing to the direction where it should face. But so let's take a look at this. So the dots player has this character controller data as I showed you before, and it has this rotation speed value which I set to 0.5, and we've got this dots camera target. This has this dots camera target data ordering. It has this minimal vertical angle and maximum vertical angle. And also I am keep in track the current vertical angle. Why this is important? Because in dots we are calculating with quaternions, but I couldn't figure out how to limit the view, the up and down view, by using quaternion. So I decided that I'm going to keep track of the current vertical angle, and based upon that I'm going to calculate the actual vertical rotation. And also we've got this vertical rotation speed as well to make sure that we can adjust how fast or slow the camera is going to rotate up and down. But I would like to point one thing out, that in the Unity physics samples, the gun doesn't have this limited angle functionality. So in theory, you can turn it all over the place. Only the mouse movement limits where you can turn it. And also sometimes I figured that it can go up, but then you cannot move it quite back, maybe because if I test it only in the editor. So this I don't like about this example, and I definitely prefer a version where I can limit the looking up and down, because I think this most suited for a first person controller. I think that's all for the editor setup. Let's jump into the code. So we've got first and foremost this input processor system. Let me just go back for a second, because we configured the look action to be this delta pointer. And then obviously the input processor on the input manager is going to handle this event. So we are just going to log the data, just so that you guys can see what kind of data comes from the input system. And we are going to set up this float to input data after we read out the actual value of this delta pointer value. And then we just set this float to input data singleton to be containing the move action, the current move input, and the look action data, the current look input. And as I mentioned before, there is one part that should be handled at character level, that is the horizontal mouse movement. We are going to calculate this horizontal angular rotation. We just have to get the look action data x part and multiply it by the rotation speed, and then we got a horizontal angular velocity multiplying the math up with the horizontal angular rotation. And now we obviously previously calculated the linear velocity, and the angular velocity could be this horizontal angular velocity. And in this way, the player is going to rotate from left to right. And obviously, in this case, we don't have to imply any limitation, because the player can rotate 360 degrees. So let's take a look at this dots camera target data. This is just for float value, so nothing special there. And also we got this rotate camera target, and we've got a rotation. This is all ref, and a dots camera target data ref 2, because we are going to update the current rotation data. So we are going to calculate a vertical angular rotation, and we have to take the opposite of this look action data, because we are going to rotate at around the right axis, and this is only works if we multiplying the look action data dot y coordinates. This is the y is the up and down. If the mouse goes up, this is a positive value, but when calculating the rotation, we have to calculate with a negative value. And when the mouse move down, that's a negative value, but then again, we have to calculate with the -1 times that data. So we've got this vertical rotation speed in the dots camera target data, and also we got the delta time. So this is the vertical angular rotation, and now we are adding this vertical angular rotation to the current vertical angle, and we are going to get this calculated rotation. And if this is larger than the maximum vertical angle, then we should only rotate as much as we can rotate to reach the maximum vertical angular rotation. And yet again, if it's less than the minimum vertical angle, then obviously we have to adjust this vertical angular rotation, and in both cases the dots camera target data's current vertical angle should be adjusted too. Otherwise, we can just calculate with the calculated rotation. So from this vertical angular rotation, we are going to calculate a rotation using this axis angle method of this quaternion struct. And we have to rotate, as I mentioned before, around the math right, which is the 100 axis. And then we obviously have to have the current rotation value. And in terms of quaternions, if you want to add two rotations together, then you should use the math mul functions and multiply these two quaternions. In this way, you can have the rotation value set up to this value. And we don't really have to calculate with velocities, because this is just the vertical rotation, and this is not going to take part in any physics calculation. And finally, when this is all completed, we have to clear out this float to input data, look action data to 0, 0, to indicate that we processed this data. And this data is no longer needed to be processed. So let's go back to Unity. And let's try our new system, and I'm going to switch to the console window. And then let's see, so if I move up, it's positive at the y-axis. If I move down, it's negative at the y-axis. If I move left, that is negative at the x. If I move right, then it is positive at the x coordinate, what we got from the input system. And actually the camera rotation works nicely. And as you can see, if I press the WASD key, we are going to move according to the direction we are facing. So if I'm facing this corner of the ground, I am moving toward that corner. And left and right and back is relative to that facing where I am facing, basically. So I think that was it for this video. I hope you enjoyed it, and see you in the next one. Goodbye for now.